We're going to hear from Helena Sykes. I dropped her name briefly earlier on when Mott MacDonald were being questioned. Helena also cut her teeth in the art of spatial data analysis at the University of Wales, as a few of us did, and is now the senior remote sensing specialist in Natural Resources Wales. She leads on NRW's remote sensing policy and strategy and carries out technical remote sensing and GIS processing. Helena's going to cover a little about how NRW has analysed and combined data sets such as content from Sentinel-2 to assess progress against the backdrop of the Welsh Government's Wellbeing of Future Generations Act from 2015.
Fantastic, great, thank you very much. And it may be me presenting this today, but my predecessor Alan Brown did most of the work on Indicator 43 the first time through before he retired in 2018, and our colleague Phil Judson works on Indicator 43 as well. Okay, so one of the things that I really like about working in the environmental sector in Wales is the Wellbeing of Future Generations Act 2015. Environment is a devolved area of legislation, and Wales is the first country in the world to have legislation that requires public bodies to think about people now and in the future when they make any decisions, which is brilliant, particularly with the climate emergency and nature emergency that are going on now that I'm sure we're all aware of. So the progress against these 7 wellbeing goals shown on the right-hand side is measured by a series of national indicators, one of which is Indicator 43, the area of healthy ecosystems in Wales. There were some quite detailed discussions in the beginning about how this should be measured, and as a proxy we use the extent of semi-natural habitat in Wales, semi-natural habitat being habitat with very little or preferably no modification by people, so things like unimproved grassland, heathland, broadleaved woodland and blanket bog. And you can see from these 6 colours across there that Welsh Government think it measures progress against 6 out of the 7 wellbeing goals in the Act. In 2018, we published a new baseline of this indicator. It's designed to be repeatable. It's a new method. It brings together a number of data sources, some of which are very large data sets. So already we can see where FME is going to come in useful for this piece of work. So the first stage of the method is a reclassification of the existing phase 1 habitat map. So thanks very much to Gwilym and Sam for covering phase 1 already. That's really useful. Phase 1 is a standardised system for mapping and classifying habitats in Great Britain derived in the 1970s, and decades of detailed field work went into a complete phase 1 habitat survey map of Wales, which is a unique and fantastic product. It's freely available along with a lot of other data sets on the Welsh Government Geoportal website Lle, spelt LLE, for those of you who don't speak Welsh or are still learning like me, as both a download and a web mapping service. But in NRW, all our GIS is delivered in the cloud and has been since day 1. So the data are delivered through an Esri geodatabase SDE, spatial database engine, from NRW's corporate data store. And phase 1 is a vector layer, and the whole 22,000 kilometre square area of Wales is covered at a bound field scale, so 0.1 to 0.25 hectare size objects. So in all, that's nearly 1 million features. And these, from their existing classes, are reclassified into semi-natural, improved and possibly improved, and you can already see where most of the work is going to be on this indicator, separating out this third category to come down on one side or the other. Is that object semi-natural or not? So one of the key ways that we did this was using remote sensing data, which of course we also needed given that the field survey started in 1979 and things have genuinely changed class by then. Sentinel-2 satellite data are free data from the European Space Agency's Copernicus programme, with visible and infrared bands across 13 wavelengths, mostly at 10-metre resolution for the ones that we use the most. We're very lucky working in government that it's pre-processed into analysis-ready data once for government by JNCC under contract from DEFRA, which applies atmospheric correction and projects all the data into British National Grid and delivers it in 100 by 100 kilometre granules. So we had access to that at the time. The imagery was segmented into objects in E-cognition, which again are around field size, just based on their similarity of pixels, and those objects were exported. So the key thing that we did with the satellite data was to look at vegetation productivity. Most vegetation that's productive early in the year in the spring is only productive because it has been artificially fertilised, mostly by farmers, and therefore we know it's not semi-natural. So we use the normalized difference vegetation index, a standard remote sensing product, which is a normalized ratio between reflectance values in the near infrared and red bands on a scale from 0 to 1. Vegetation is reflective in near infrared wavelengths, but red is absorbed and used in photosynthesis. So the more productive the vegetation, the higher the NDVI. And Alan found that the red edge band 6 from Sentinel-2 had a really good contrast in about April time between improved and semi-natural vegetation, but later in the year that contrast isn't there because the semi-natural vegetation has come into productivity on its own naturally. So we use 2 seasons of satellite imagery, one from spring, March, April time, and one from summer, June, July time for each area. We had to split this across 2 years, 2016 and 2017, just because of the availability of cloud-free imagery. We would have preferred it all to be from the same year for consistency. So for each of those satellite images, NDVI thresholds between semi-natural and not semi-natural were empirically derived from pairs of points, one that's known semi-natural and one known not semi-natural, that are very close to each other for 2 test areas in North and South Wales. This was done remotely rather than in the field, just due to time constraints at this point, but given that we've still got some of the same people working for us who actually did the field work on the phase 1 survey in the 90s, the 80s, even the 70s, the knowledge in NRW to do that remotely is pretty huge. And then in R, we did some zonal statistics showing the average NDVI for each object from the NDVI of its pixels for the spring and the early summer. And that is a key part that I'm looking to bring into FME using the R caller on our next time of running this through. The next data set that we brought in was, we have a really good digital elevation model of Wales in NRW. It's made in-house from 1 metre LiDAR data where available, 2 metre LiDAR data where there's no 1 metre, but we do have 2, and any gaps are filled with 5 metre resolution NextMap data, and that's why we can't make this data set open, unfortunately, because that is licensed data. But we've currently got contractors flying national LiDAR coverage at 1 metre resolution over the next 2 winters, so our next elevation model from that will be a completely open product. So there are terms in the equations in the zonal statistics using the average elevation, slope, aspect, and distance north of each of the objects. The slope and aspect we use for an NDVI warmth term, just because of the impact on solar insolation of the slope and aspect and its effects on vegetation productivity. And again, the elevation and distance north affect the expected date of the start of the natural growing season. The difference from south to north Wales is usually a couple of weeks each year, all of the things being equal. And then the last data set we brought in, just as a bit of a sense check, was agricultural payments data from Welsh Government, which is the data that's used for paying farm subsidies, where farmers declare basically what crops are in each field. The polygons are LPIS, Land Parcel Identification Scheme polygons, so that was over 500,000 features, and the data come from the IACS data Integrated Administration and Control System, and with the data for all the time periods that we had it, that was over 13 million rows of data, and that just led to a simple flag for each object as an attribute, 1 or 0, is it improved agricultural, which rules it out as semi-natural or not, in which case it can still be included in the analysis and it still might be semi-natural. So it's time to put it all together, and this is where FME comes in, and by coincidence this is pretty much the point that Alan retired and I took over and moved everything into FME, as I'm prone to doing. So is each object semi-natural or not by Welsh Government's definition? And the decision is all based on a rule set for each object from the attributes we derived in the previous stages from the phase 1 habitat map classification, the NDVI thresholds from the spring and the summer satellite imagery, which in turn needed the elevation model, and the agricultural data from Welsh Government. And in addition, we had to process the data in 8 different project areas that you can see on the left-hand side, partly just because of the way that the satellite data was delivered and just so it didn't get too computationally intensive, and we didn't end up processing large areas of sea. And at the end, all that had to be put back together just to create one product for the whole of Wales. So you can see the rule set on the right-hand side. It's looking at objects that are not already counted as semi-natural from the phase 1 classification and that had low photosynthetic activity from the NDVI in the spring, but high in the summer, and were not declared as an agricultural crop in the IACS data. And we didn't use many different FME transformers in this process and in the workbenches we built, but we did use some of them lots and lots of times. Things like the bounding box accumulator and the clipper were really crucial at the beginning for cutting up all the other data sets to match the satellite imagery extents. And again, at the end, when you can see that some of these project areas on the left-hand side overlap, and we had to decide which set of polygons and which attributes take precedence in those areas of overlap to produce the national product, which was based on things like how close to our first choice of satellite imagery we'd been able to get. And then the attribute creator was used at each stage, where each object had a set of attributes that was built up over time for things like the reflectance in the different bands, the NDVI, the flag for whether Welsh Government's agricultural data said it was improved or not. And then right at the end of this, we had one area calculator and one aggregator that put all these millions of objects back into just three categories: semi-natural, candidate semi-natural, which we've just had to leave sitting on the fence about, and everything else. So terabytes of data, months of work, millions of objects, and we came up with one number at the end. Wales is 31% semi-natural, which means that the vast majority of the land area of Wales has been impacted by humans. Obviously, we'd like to see that 31% increase, but we know it's going to be a slow process. We also looked at how much of the area is semi-natural in the uplands, which is defined as coming down as far as the upper limit of field enclosure, and 74%, so nearly 3/4 of Wales above that altitude, is actually semi-natural. But in the lowlands, it's only 19%. As you can see, most of it is farmland, urban, heavily impacted by humans in lots of ways. So these numbers are the baseline. This was the first time the indicator was run with this method, and in the future, the same FME workbenches will be reused again with more up-to-date data. We won't need to do that phase 1 habitat reclassification at the beginning because that's a static product, but we will have new satellite imagery. Hopefully we'll get enough cloud-free imagery from 1 year to have a consistent data set there, and this year is looking very promising for that. And I know that in my abstract I said that we wanted to use more field data to improve the NDVI thresholds empirically. It would have been done using the EarthTrack app from the Welsh Government Aberystwyth University Living Wales project for field data recording, but I'm afraid that's not going to be happening in 2020 for obvious reasons. So thank you very much. Here are some links to access NRW data, to get in touch with us, and to access our social media channels. Thank you.
Thank you, Helena. It's really heartening to see that at least one country in the world is thinking a little bit about the future. We've got one main question in that has been asked, and I guess you're probably one of the best people qualified to answer the question. Somebody said, what is Sentinel-2? Is there a Sentinel-1 and a Sentinel-3?
There are indeed. So the Sentinel series of satellites come from the European Space Agency. Sentinel-2 is the kind of satellite imagery that most people are familiar with sort of the visible wavelengths that look like a photograph, and the near infrared that's really good for vegetation and moisture, things like that. Sentinel-1 is a radar satellite, well, 2 radar satellites, Sentinel-1A and 1B, which operate at much longer wavelengths and give you sort of radar echoes rather than actual image. I spent 4 years in a room in Swansea processing radar echoes. Yep, back in the day, and I'm still in Swansea now. And that data for the kind of applications we have in NRW is useful for things like flood delineation, just because water shows up really well in that. And we had some excellent analysis-ready Sentinel-1 data from our Aberystwyth University at the height of the flooding in February that actually was so good it saved us from having to invoke the International Disaster Charter at that point. Sentinel-3 also exists, and I think it's got sort of some altimetry and some ocean instruments on it. There's also Sentinel-4 that hasn't been launched yet, and Sentinel-5P, a precursor mission to Sentinel-5, which is mounted on another satellite, and we've reached the limits of my knowledge about that now.
It's fascinating stuff. I mean, the EO stuff that's going on at the moment is really fascinating. So it's lovely to get a bit of an insight into that, Helena. Thank you very much indeed.
Thank you.